What was it? 9 heads. What's the probability of 9? 0.122. Isn't that what we got for the very first problem, right? All right. So this is just a collection of all the things that could happen. If I flip a coin 14 times, I can get anywhere from 0 heads to 14 heads, right? What do you think 0 plus might mean? It's not 0, but it's really, really close. I like it. So it's really unlikely to get 14 heads if I flip a coin 14 times. In fact, if you get 14 heads in a row, what are you going to think? Something happened to the coin. Something's not right about the coin. Something's weird in the universe. Right? Maybe not 14, but if you got like 20 heads in a row, then you're like, okay, this is weird. I got to go play the lottery or something. I'm in a weird place where things are happening. Are you guys kind of with me? That would be evidence that something strange is happening. Most likely the coin was messed with. Is it impossible? No. Is it likely? Hell no. Very unlikely. All right. Maybe. What's the most likely thing to happen? 7, which kind of makes sense. The average should be at least close to, if not the most likely thing to happen. The average should be, and that's why we call the average the expected value. Okay, maybe. For a binomial distribution, that is, right? Okay. All right. So we just did this one. Can you see from the chart what this was? We calculated this earlier. If I remember correctly, did we? Yes, we did. From the chart, what's the probability at most 6 heads? So what would I add up? What's at most 6 mean? Yeah. From 0 up through 6. So if you add these up, what do you get? 0.395? And that's pretty much what we got earlier, right? We just did at most 6 heads, and we got 0.395. All right, I like it. And of course, that only makes sense because these numbers came from the same place that these numbers came from. No way. Not exactly David Blaine level, but all. So probably at most 6 heads would be, we calculated it earlier, but now we can add them up here, and we get about 0.395. All right, so let me stop there for a second. What's up? You okay? Yeah. If you add up 0 through 6, those probabilities. Yes, sir.
To show our work, would it be like? Could we say that we use a calculator, or would you want us to add?
All right. Let me make sure you understand. A lot of the stuff on this handout is just concepts. We're just exploring some ideas. These first 2 things, I must see this formula set up. Period. What you do after that is up to you. But what I love it is when the formula is not set up right, but then the right answer is there. You know what I mean? So you need to know how to set the formula up right. After that, you can do whatever you want to, but you better make sure the formula leads to the same answer you get. All right, I like it. All right. So this is what we've already talked about, but I really just want to hammer this home. The area of 9. How wide is this rectangle? 1, because it goes from what to what? What's here? 8.5? 9.5. So that's 1 wide, and how tall is it? 0.122. So what's the area of that? 0.122, which is the probability of 9. So this is that idea I was trying to get us used to. Once we start to step into continuous distributions, then the area will relate to the probability. So when I have rectangles, almost too easy to believe. But we're going to get to this now. We need some help, right? So unfortunately, my printer loves to mess with me, and I didn't want to print this whole thing out. But there's a uniform distribution from A to B. And there's what we're going to get into now is a normal distribution. And that's where the z-score chart will come in handy. So I'm going to give you the z-score chart, and then we're going to talk about how the hell to use it. All right? I'll start with this. This is your z-score chart. Let me say it before I give this to you. Bless you.
What's this one?
This is your z-score chart. You will want to bring this with you to tests. You will want to not write any notes on them, because I will collect them from you every test and then give them back to you when I finish grading the test. You with me? So you're going to need this for the rest of the semester, basically. If you lose it, I will have some extra copies with me. But don't write notes on this. Don't write little something to yourself. That'll suck. You'll lose points. Okay.
Do you have like copies of it on your page?
No. I could put them up there. So if you remind me about it, I can put it up there. The first thing we're going to do with this, once everybody gets one, is make sure that empirical rule is still on here, because we know that empirical rule is true. So if this guy disagrees with empirical rule, then screw this guy. Alright, shit, I lost count. I was too busy saying screw. Let's see what happens. So basically what this is it's like the empirical rule on steroids. So empirical rule, I only know 1, 2, 3. That's all I know. So let me tell you how to read this, because it's sort of like a road map or something, how to read this thing. Let's recover the empirical rule. The first part of the empirical rule, it says that within one standard deviation of the mean, there should be 68%. So let's do this. Can you guys help me out? If there's 68% in here, how much should be outside? 32%. So how much should be just on this one side? About 16%. Are you guys with me? If there's 68% in, there must be 32% out. So there must be 16% on that one side. Is everybody cool with that? It's symmetric, so I just cut it in half. Symmetric. Okay, exactly. That's what I always think when I said it. So here's how we recapture this. If I look up a z-score, and this is how you look up a z-score. Currently I want to look up the z-score -1. So make that into like a dollar amount, -1.00, right? You guys with me? So I can look up to 2 decimal places on this thing. So here's how this works. -1.00. Oh, do you guys see that? -1.0. Oh, if I wanted -1.03, I would go -1.03, and I would go here. Let me do this again. If I want -1.07, I would say -1.07. I would use this number here. All right, so let's go to. Does everybody sort of see how that works? So -1.00, what do I get? And if you round that to a couple places, you get 16%. And of course, again, it's not like a moment. It's just. Of course, it's going to be the same thing because that is built off of the empirical rule, just more. So, for those of you who know a little bit more math, there is a function that describes this curve, and they just integrated, which is a calculus word that means found the area under that curve using calculus. So that's where all these numbers come from. Right? For the rest of us, they did some shit to figure out the area. Right? So they figured out that this area here is 0.1587, which is 16% when I round it. The empirical numbers are rounded a bit. Okay. So now let's do a couple more things together, and then I'm going to unleash you on this handout. So let's say I wanted to find out if I had a normal distribution. Now be careful. This only works if it's normally distributed. Because then I have empirical rule, which is very specific. If it was some other distribution, some weird ass thing, this will not do anything for me. Because then chubby dude's in effect, and chubby dude's very vague to begin with. I mean, it's just who knows where shit is, right? So I need this to be normal, or else I can't use this. So a big part of statistics is, when can I say it's normal enough to use this? Why is that a great place to be? Because I've got all the freaking answers just waiting there for me. I just got to look them up. If I can't use this, I'm like, oh shit, I got to do something weirder. So if I have a normal distribution, and I wanted the probability that z is less than, let's say, 1.24. Z is less than 1.24. So which side do I want to look at? The negative z-score side? Or the positive z-score side? Well, is it a positive or a negative z-score? Is it a positive or negative z-score?
Oh,
Positive. So the way this chart works, any z-score I look up, it will tell me the area below it. You see how that picture gives it away? You guys kind of with me. Any z-score that you look up, you'll find the area that is below that z-score. So it only makes sense that when I look up the z-score of 0, 0, I get 50%, because how much is below the mean in a normal? 50%. So now if I look up 1.24, what do you guys get? 1.24. 8925. So below a z-score of 1.24 is 89.25% of the data. So this would be 0.8925. And now you guys see why I was making all the probabilities out to 4 places. Because it matches with the chart. I like it. It might keep. Okay, cool. Let's do another one, because believe it or not, it gets a little bit freaky. What if I said the probability that z is more than 3.02? So if you draw a picture for yourself, here's 0, where's 3.02? Over here. Now trust me, I have people put 0 there and they just put 3.02 wherever the hell they happen to feel like it. It's a freaking scale, so put it in the correct place. So 3.02, somewhere over there. So now watch this. This is the way you should do this kind of problem. Shade in the area I want. What area do I want? The area that's above 3.02, right? Now when I look up 3.02 in the chart, what area will it give me? Area below it. So when you look up 3.02, what do you find? 3.02. 9987. So when you go, trust me, my God, everybody listen. The people that don't do this are the ones that make the silliest mistake. Immediately put that number down here, 9987, right? I forgot what it was. Yeah, 9987. I like it. Is that your answer, though? No, you were nice to yourself. You told yourself earlier, I need that stuff. I got that stuff. Well, how much is this then? It must be the rest. And I don't know if you guys remember, make 9, 9, 0, make 9, 9, 0, make 8, 9, 1, make 7, 10, 3. Or just do 1 minus that and you can't figure out. I love how some of you guys are looking at me like you're confused. Don't do the damn thing if you don't like it. Just do 1 minus 0.997. But 1 minus any decimal less than 1, real quick, because this happens a lot here. If I want 1 minus 0.4281, how do you make 4 become 9? 5. How do you make 2 become 9? How do you make 8 become 9? 1. How do you make 1 become 10? Done. Yes, ma'am. Here? Because 1 minus this is that. Because the whole picture, of course, is an area of 1. So if I got one side, the other side must be 1 minus that side. Alright. Alright, let's do one more together. What if I want the probability that negative 1.73 is less than z is less than 1.11? Draw the picture first. Always draw the picture. I won't take points off if you don't draw the picture, but I will take more points off if you make mistakes and don't have the picture. Oh, I'm so mean. Oh, you should be used to that by now. So mean because I'm trying to help you. Oh, I'm such a dork. Alright. Here's 0. Where's negative 1.73? 1.11? So that's the area I want. Now how the hell am I going to do this? If I look up, I like it. If I look up 1.11, don't I get all of this area? I get the whole area below it. But I want to stop here. So if I look up this area, I can just subtract the areas. Never subtract z-scores, because what does a z-score tell you? How many standard deviations from the data point of view? It also tells you where you are, just to make it really quick. It tells you where you are. If you subtract 2 z-scores, you are now somewhere else. So I subtract areas, not z-scores. Does that make sense? What's up? What's the matter?
I don't even know where I'm lost. I'm just lost.
Is everybody cool with these examples?
Yeah.
Everybody's cool with those examples? I hope so, because I already went to the next page. So you got to ask me the minute it doesn't make sense. Now, if you're lost with this one, that's okay. We haven't finished this one yet, so you're not really lost yet. So let me ask you. If I look up 1.11 on the chart, it gives me this entire area all the way down, right? Okay, good. Is that my answer? I don't want this area. So if I knew what this area was, couldn't I just subtract it off? And then I would end up with the area that I want. So if I want to know this, how long that is, and I know from here to here is 7 feet. If I only knew how long that was, I could figure out how long. If this was 2 feet, how long is this? 5 feet. Right? Right? If this whole thing is 7, and this little piece is 2, how long is this piece? 5. So if I knew this whole thing, and if I knew this little piece, I could subtract them to get this much, the part that I want.
But they're minus 1.
Yes. So subtract the 2 areas to get the area in the middle. So what area do you get for 1.11? When you look at 1.11, 8665, I like it. So I put that right here, 8665. What area do you get for negative 1.73? 0418.
0.04.
I like it. So now you just got to do 0.8665 minus 0.0418.
Didn't you just say you can't subtract the z-scores?
Can't. What are these? These are areas. I like it. These are z-scores. Don't subtract those and look that number up, because now you're getting a whole different place.
That's what confused me. Because I thought
Oh, I got
those
you.
were the z-scores.
No, those are the areas. These are the z-scores. See, the problem tells you what's the probability of the z-scores between those two. That's why I can look them up. What's the only thing I can look up here? If I'm looking at this number here, I better have a z-score to use the z-score chart. I like it. When I get an answer, what are all these? These are all areas, or otherwise known as probabilities. I like it. I like it. I like it a lot. Okay, so you guys, if you might, if you want to group up with somebody near you, feel free. If you'd rather not, if you're a lone wolf, be that way. I want you to work on the back of this handout here. On the back are a bunch of problems. Some of them will be challenging.
Area.